In section 3.3, we will solve systems algebraically. The goals of the lesson are to solve linear systems by substitution and also to solve linear systems by elimination. So in our first example, we can see that we have a linear system. We have two variables and two equations to work with. So with this problem, we are going to solve this by substitution. And when we substitute, since y is equal to this expression right here, anywhere we see y in the top equation, we can substitute that in for that y. So the way that that's going to look is we're going to take this top equation and we're going to plug in negative 7x minus 1 in for that y. And it's very important that we plug that in parentheses. The reason that's important is that here I do need to make sure I'm distributing this negative into both parts of this expression. So now I've got negative 5x, this becomes a positive 7x, and then plus 1. From here I can clean up the left side. Negative 5x plus 7x is going to give me 2x, so now I've got 2x plus 1 is equal to 1. From here, if we subtract 1 on each side, we get 2x is equal to 0. We divide by 2. And that gives me x is equal to 0. Now remember, it's only a special case where we get infinitely many solutions or no solutions if both variables completely cancel. So since I am not canceling any variables here, I am going to get a solution. So sometimes people can get confused when we get x is equal to 0 like that, but again, we did not cancel out the x's here. So the next thing we're going to want to do is plug that 0 back in for one of the expressions. And I'm going to choose to plug that in for the bottom one because I'm trying to find y, and y is solved for in this expression. But if you did this to the top, you should get the same result. So here I've got negative 7 times my x value that I now know, which is 0, and then minus 1. Well, negative 7 times 0 is going to be 0, so I just get y is equal to negative 1. So now I want to write my answer as an ordered pair, just as we did in section 3.2 with graphing. Our answer becomes it's the x value first and the y value second. So I get 0, negative 1. Now I do want to test the value for both equations before saying that this is for sure my answer. So if I plug in a 0 for x here, and I plug in a negative 1 for y here, this is going to turn into a 0. This will be a negative 1, which is a positive 1. So I'm getting 1 is equal to 1, which is a true statement. So it checks out with the top equation. For the bottom equation, I'd plug in a negative 1 for y. That'd be equal to negative 7 times 0, which will cancel, and then minus 1. So now I've got negative 1 is equal to negative 1, which again is a true statement. So now that we're confident about that solution, we can move on to the next problem. So here are two more examples that we could use substitution for. So I'd like you to try to do both of those problems, and then we'll check our answers. Now in number 2, we're taking 6x minus 11, and we're going to plug that in for y in the other equation. Again, we want to make sure that we're plugging that in parentheses. It's going to become negative 2x minus 3, and then again, we're not writing that y. We can't solve it if we have both the x and the y in this equation here. So we take this and we plug it in for y in parentheses, and now when I distribute that negative 3 in, I keep the negative 2x, this becomes negative 18x, this becomes positive 33, and it's equal to negative 7. Now if I clean up the left side, I've got negative 2x and negative 18x, which will combine to give me negative 20x, and then if I subtract the 33 over, I'm going to get negative 40 on the other side. From here, if I divide both sides by negative 20, my answer for x is going to be 2. Now, once again, my answer should be an ordered pair. So I need to plug this x value back in for x in either one of the equations. My strategy, once again, is going to be to plug it into the top equation. Again, although both work, since I'm looking to solve for y, I'd rather plug it into the top one. That's going to give me y is equal to 6 times 2 minus 11, which is 12 minus 11, therefore 1. So now I'm thinking that my answer is 2, 1. Well, once again, I want to double check that for both of these equations. So in the top equation, I have 1 is equal to 6 times 2, which is 12, minus 11. Therefore, I'm going to get 1 is equal to 1, and that's a true statement. For the bottom one, I'll have negative 2 times 2, so negative 4, minus 3 times 1, which stays negative 3, and negative 4 and negative 3 do combine to give us -7. Therefore, we can say that 2, 1 is the correct answer for number 2. For number 3, same thing. We take what y is equal to, and we're going to plug that in for the y in the second equation. This becomes -3x plus 3 times the quantity x plus 3 equals 4. We can distribute. We are going to end up getting, we keep the -3x, we get 3x plus 9 here. Now in this case, the -3x and the positive 3x will actually cancel each other, and I'm going to get, either I can leave this as 9 is equal to 4, or if I subtract over that 9, I would get 0 is equal to -5. I could have even subtracted over this 4 and gotten 5 is equal to 0. Any of those situations would give me something that is not a true statement, therefore it's no solution. Another thing we could check is, like we saw in section 3.2 with graphing, if these come up with parallel lines with different y-intercepts, that's going to make them no solution. So I could take a minute to rearrange this equation so that it's solved for y and compare their slopes and y-intercepts. Now we move on to elimination. And with elimination, what we're going to do is make sure that our x's are lined up, our y's are lined up, and our constants are lined up. Once that happens, what we want to do is try to figure out if we're going to cancel our x's or our y's, or whatever variables are involved in your problem. Here it's going to be easier to cancel our y's. So I will start by multiplying that bottom equation by 2. And we can't just multiply the y by 2, we have to multiply all 3 parts by 2. Now that is going to give us, I'm leaving the top equation alone, the bottom equation is going to turn into 18x plus 2y is equal to 40. From here, what happens is the y's will cancel just as we wanted them to. -10x plus 18x is going to combine to give us 8x, and then on the other side, -16 plus 40 combines to give us 24. Now if I divide both sides by 8, I end up getting x is equal to 3. From here, we take that x value and we plug it back in. Again, to either equation, a lot of time I'll look at which one looks like it'd be the easiest to work with, and I'll plug it into that. Here I chose to plug that into the bottom equation, giving me 9 times 3 plus y is equal to 20. From here, 9 times 3 is 27, so I have 27 plus y equals 20. If I subtract the 27 over, I'm going to get y is equal to -7. So here my answer is going to be 3, -7. Once again, I'm going to want to test that value for both equations. So plugging in a 3 here is going to give me -30. This right here is going to be a +14. Those do combine to give me -16. In the bottom one, I'd get 27 minus 7, which does equal 20. So now we've proven that that is the correct answer. So try 2 and 3 on your own, and then we'll check our answers. So in number 2, I chose to multiply the top equation by 5 so that I would cancel the y's. You could have also multiplied that top equation by a -3. So if you chose to do that, follow along with my work here, but your work isn't going to match up with mine until the very end. Hopefully we have the same answer. So when I'm multiplying that by 5, I got 10x plus 5y is equal to 100, and I'm leaving this equation alone. From here, my y's do cancel, and now I'm left with 16x is equal to 112. I can divide both sides by 16 here, and that gives me x is equal to 7. So now I'll plug that back into one of my equations. I chose the top one. I've got 2 times 7 plus y is equal to 20. I get 14 plus y equals 20. So then I'll subtract the 14, and it gives me y is equal to 6. So now I'm thinking my answer is 7, 6. As we check that answer here, I'm going to get 2 times 7, so 14, plus 6, which does equal 20. Down here, I would get 6 times 7, so 42, minus 30, which does give me 12. So since that is the correct answer, it worked for both, we can go ahead and move on to number 3. Now here, I need to do a little bit more work. I'm multiplying the top equation by a 2. I'm also multiplying the bottom equation by a 5. I chose the x's here since they were already opposite signs. I knew I just needed to get the numbers to be the same. So that is going to give me the following equations once I multiply the top equation all the way through by 2 and the bottom all the way through by 5. From here, my x's cancel. So I'm left with -51y equals -51. If I divide both sides by -51, I'm going to get y is equal to 1. From here, when I plug in that 1 for y in either one of the equations, I chose the bottom one here, I end up getting 2x minus 7 equals negative 17. As I add the 7 over, I get 2x equals negative 10. Dividing both sides by 2 gives me x is equal to negative 5. So now that I think my answer is negative 5 comma 1, I do again want to check that for both equations. Here, this would be 25 minus 8, which is going to give me 17. This would be negative 10 minus 7, which is negative 17. So that worked for both equations. Finally, we want to use all three methods to solve the system. So we should expect to get the same answer in all three of these situations. For example 4, we're going to take this system and we're going to solve it with all three methods. So hopefully we realize that since it's the same system, no matter which method we're using, we should get the same outcome. Now, in order to graph this, we are going to want to put both of these into slope-intercept form, which is y equals mx plus b. So for the top one here, I'm going to get y is equal to 2x minus 1. And how I got that would be to subtract 4x on each side and then divide everything through by negative 2. The bottom one's a little easier. All we have to do here is subtract 2x, and that's going to give me y equals negative 2x minus 3. So as I graph them, blue one, I'm starting at negative 1. Slope is positive, so I know it's going to go up from left to right. And it goes up 2 and over 1, and we'll connect that. Again, we want to use a straight edge. For the one that I have in red, I'm going to start at negative 3. This is a negative slope, so I know it's going to look something like that. This one goes down 2 to go over 1, and we connect. And then we look for its intersection point. Now, its intersection point here might be a little bit hard to read. We can kind of see that it looks like it's maybe between grid marks here. So I'm not going to write down an exact value for this, but I'm going to see what I get for substitution and elimination and see if that kind of matches up with the value that I'm getting for graphing here. With substitution, we have a choice. You can solve for any of the variables here. We can solve for this x, this y, this x, or this y. What's always going to make the most sense is to solve for the one that has a coefficient, the number in front of it is 1. So we can do that, or we can also just set these two equal to each other. And that's what I did here. So because these are both equal to y, I'm basically taking this 2x minus 1 and plugging it in for this y here, giving me this equation here. I start by adding 2x over to each side. That's going to give me 4x minus 1 equals negative 3. I add 1 to each side. We get 4x equals negative 2. Divide both sides by 4. And negative divided by positive is negative, and then 2 over 4 will reduce to 1/2. From there, I still have to figure out what my y value would be then. So I'm going to take that negative 1/2 and I'm going to plug it into the equation that we used right here, y equals 2x minus 1. So I've got 2 times my x value that I just got, the negative 1/2, and then minus 1. Well, 2 times negative 1/2 is going to be negative. The 2's are going to cancel, and I'm going to end up just getting negative 1 minus 1, which is negative 2. Now, right now, I'm thinking if this solution is in fact negative 1/2 comma negative 2, does that match up potentially with my graph? And it looks like it does. And then finally, for the elimination here, we're going to take our original equations and determine what is going to make the most sense to cancel. In this problem, we could cancel the x's, and we would do that by multiplying the bottom equation by a negative 2. Or we can choose to cancel the y's, and we would do that by multiplying the bottom equation by 2. And that's what I did here. So I'm going to rewrite this equation. 4x minus 2y equals 2 is not changing, but the bottom one is. If I distribute that 2 to everything, I end up getting 4x plus 2y is equal to negative 6. From there, if I cancel out my y's, I'm left with 8x is equal to negative 4. I'll then divide both sides by 8. Remember that this is not 8 divided by negative 4. It's negative 4 divided by 8. It's going to stay negative, and then 4 over 8 reduces to 1/2. So it's good that our x values are checking out so far. Now we'll take this -1/2 and I can plug it into any of the equations here, either that top one, this bottom one, or the one that I got once I multiplied by 2, which again is going to be my last choice. Here I chose to use this bottom one right here. So I did 2 times our x value, which is -1/2, plus y equals -3. 2 times -1/2, the 2's are going to cancel. I'm left with -1 plus y is equal to -3. Add the 1, we get y is equal to -2, and which again checks out with this. So in all 3 cases, I did end up getting -1/2 comma -2. Now for homework, you are going to work on Delta Math, and that is going to be a lesson on substitution and also elimination.